All right, let's just jump right in. We all use numbers every single day, right? And when we do, we kind of picture them laid out on a perfect line, stretching on forever. But what if that mental image, the very foundation of how you think about numbers, is just wrong? No, I'm serious. What if these crucial numbers, pi, the square root of 2, what if they aren't real things at all? What if they're just incredibly useful stories we tell ourselves? It's a wild thought, and believe it or not, it's at the center of a huge debate that's shaking up the world of mathematics.
And this isn't some quirky late-night thought experiment. This is a real philosophical battleground. You've got mathematicians fighting over the very definition of reality itself. On one side, you have centuries of tradition, and on the other, you have this radical new challenge that could literally change how we think about everything.
Okay, so let's meet the heavyweights. In this corner, you've got the classical view, represented by Professor Jim Franklin. He believes numbers are these perfect, abstract ideas that exist out there in some conceptual space. And in the other corner, you have the challenger, Professor Norman Wildberger, the leader of the finitist camp. His rule is simple. If you can't define a number and you can't compute it, it ain't real. We're talking two totally different views on what it even means to exist.
So let's really dig into the challenger's case first. Why do the finitists think that our whole understanding of numbers is, well, built on shaky ground? It really all comes down to one thing: a demand for absolute rigor.
The finitist attack really comes in three ways. First, they say that concepts we just take for granted, like number or infinity, are actually super fuzzy when you try to nail down a definition. Second, and this is a big one, you can't actually use pi in a calculation. Think about it. You've always used an approximation, right? 3.14, 3.14159. You can't compute with a number that goes on forever. And third, any mathematical proof that relies on finishing an infinite number of steps is based on a fantasy, something that's physically and logically impossible.
So this all boils down to one really powerful, almost common sense question. Finitists believe math has to be about stuff we can actually do. If you have a symbol, but you can't give it a clear, computable definition, then it's just a symbol. It's not a number.
All right, so that's a pretty strong case. How does the classical view, the one most of us probably learned, fight back? Well, Professor Franklin has three pretty intuitive and deceptively simple arguments to defend the idea of abstract numbers.
First up, he says the name is not the number. The idea is that a number is this perfect concept that exists completely separately from our clumsy attempts to write it down. Just because our name for pi is this messy, endless decimal, that doesn't mean the true, perfect idea of pi isn't out there.
His second point feels like a bit of a logical trap. He says, look, you have two choices. Either there are an infinite number of numbers, or there's a finite set. And if the set is finite, well, then there has to be a single biggest number. The idea of a biggest number seems absurd, so it kind of forces your hand into accepting infinity.
And finally, the argument we all learned as kids. You can always add one. Take the biggest number you can possibly imagine. Now add 1 to it. See? It just seems to prove that numbers have to go on forever. Simple, clean, case closed, right? Well, not so fast.
Now, this is where it gets really, really cool, because the finitists don't just disagree. They take each of these classical arguments and systematically take them apart, showing where they think the logic breaks down.
Let's go back to that first one. The idea that a number is some abstract thing separate from its definition. The finitists look at that and ask a very simple question. In mathematics, what else is there besides the definition?
And their reply is sharp. They say, in math, the definition is the object. There is no magical pi floating out there in some platonic heaven. All we have is its definition. And if that definition is an infinite, non-computable process, then the object itself isn't well defined. It's just a symbol pointing at an idea we can never fully grasp.
Okay, what about the slam dunk argument, you can always add one? That feels impossible to argue with, doesn't it?
Well, the finitists say, yeah, you can always perform the operation of adding 1, but does the result always have meaning? Think about it. The number 5 means something. The number 5 trillion means something. But what about a number so vast it would take more atoms than are in the universe just to write it down? At that point, adding 1 creates a new symbol that is so complex it's functionally meaningless.
And finally, what about that logical trap that a finite set of numbers must have a biggest one? The finitists say, nope, that's a false choice.
And their answer here is just beautiful. They introduce this concept of a gray area. Imagine the number line isn't a road that just ends at a cliff. Imagine it's a coastline stretching into a thick fog. The numbers nearby are crystal clear, but as you look further and further out, things get hazy. The numbers get so complex that they lose their sharp definition until they just blur into an indistinct mist. So the set of definable numbers is finite, but it doesn't have a single biggest one. It just fades out.
So, if the old ideas have holes in them, what do we replace them with? What does a finitist world look like? It's not about destroying math. It's about rebuilding it on a more honest, solid foundation.
This new framework is all about being more precise. First, you toss out the vague idea of infinity and replace it with that foggy gray area. Second, you admit that a perfectly smooth line in geometry is fundamentally different from a number line made of discrete, computable points. They are not the same thing. And finally, you keep using pi. You just have to be honest and call it what it is, an incredibly useful approximation, which, let's be real, is how every engineer and scientist has been using it all along.
And here is the most crucial part. This doesn't weaken math. It actually strengthens it, especially for fields like computer science, which live and breathe in the world of the finite and computable. This provides a much more honest and logical foundation. You gain all this philosophical consistency without losing a single bit of practical, real-world power.
Okay, wow. We've gone to the very edge of mathematical philosophy and back. So after all that, what's the bottom line? What's the main thing to remember here? First, the reality of numbers is not a settled fact. It's a live, deep, and fascinating debate. Second, the finitist challenge is simple but powerful. For a number to be real, it has to be something you can define and calculate. This view forces us to be more honest about fuzzy concepts like infinity and to ground math in what's actually possible. And, maybe most important of all, we can adopt this more rigorous view, get a clearer philosophy, and lose absolutely none of math's real-world power.
So, I'll leave you with this to chew on. We often think of mathematics as this grand tool for understanding the infinite, but maybe, just maybe, its true strength, its deepest power, comes from being honest enough to recognize and define its own limits.